Hello everyone. In my previous video you have seen the switching characteristics of power MOSFETs. If we want to achieve a higher switching speed, we need to reduce the turn on time and turn off time of the power MOSFET. So if we want to reduce the turn on and turn off time of the MOSFET, we can include a RC network in the circuit. So the initial charging current of the capacitance will be Ig is equal to Vg by Rs. So this is the initial charging current of the capacitance. So once the capacitance gets fully charged, the current Ig will be equal to Vg divided by Rs plus R1. Okay, so once it is fully charged, so the current will be Vg by Rs plus R1. So what will happen? The initial current will be very high so that the turn on time can be reduced and the switching speed can be increased. So this is the gate voltage which is applied. So what is gate to source voltage VGS? So the steady state value of the gate voltage, which is VGS, you can write it as RG, that is the voltage across which we are finding, that is VGS, into the supply voltage which is VG divided by the total resistance, that is Rs plus R1 plus Rg. This is the steady state value of the gate voltage. This resistance Rs is nothing but the internal resistance of the gate drive source. Internal resistance of the gate drive source. This is one way in which we can achieve a reduced turn on time, and in turn we can increase the switching speed. So initially you can observe the current is very high, later on the current will reduce. The second arrangement in order to achieve a higher switching speed is to use a totem pole arrangement. Okay, this is a totem pole arrangement. So if we want to achieve a higher switching speed, one of the main feature is the gate drive circuit, that is, this is the driver circuit. This entire thing is your driver circuit for the MOSFET, this part. Okay, now this gate drive circuit should have a low output impedance. It should have low output impedance and it should have the ability to sink and source relatively large currents. So this can be achieved by using an NPN and a PNP transistor. So this NPN and PNP transistor, it acts as emitter follower and it produces a very low output impedance, and the transistors will operate in the linear region rather than in the saturation region, so that you can minimize the delay during turn on. So the gate signal, whatever is required for the MOSFET, is generated by this emitter follower along with the op amp, which gives you sufficient gain. And you can see that there is a capacitor C which acts as a feedback. It regulates the rise time and fall time. That means it will regulate the turn on time and turn off time of the MOSFET. And there is a diode connected across the capacitor. It will allow the capacitor to get charged only in one direction. So this is an arrangement of the gate drive circuit for a Mosfet in order to achieve higher switching speed. So you can either add a RC combination or you can go for a totem pole arrangement in order to reduce the switching speed of the Mosfet. To increase the switching speed of the Mosfet. Thank you.